Hello all and welcome back. In this video, we are going to cover Amazon RDS or Relational Database Service, followed by a quick demo. Amazon Relational Database Service or RDS is a completely managed service that makes it easy to set up, operate, and scale a relational database in the cloud. It provides a cost-efficient and resizable capacity while managing time-consuming database administration tasks such as hardware provisioning, database setup, patching, scaling, backups, and freeing you to focus on your application and business. Amazon RDS currently supports PostgreSQL, MySQL, MariaDB, Microsoft SQL Server, Oracle, and DB2 database. RDS provides a lot of features and benefits. You can scale the CPU, memory, storage, and IOPS independently. It manages backup, software patching, automatic failure detection, and even recovery. It supports periodic automated backups, and manual snapshots can be triggered as well. Backups can be used to restore a database, and the restore process works reliably and efficiently. RDS supports multi-AZ deployments, which provides high availability with a primary instance and a synchronous standby secondary instance that can fail over seamlessly when a problem occurs. RDS provides elasticity and scalability by enabling read replicas to increase the read scaling. RDS also supports IAM users and permissions to control who has access to the RDS database service. Databases can be further protected by putting them in a VPC, using SSL for data in transit encryption, and KMS using data at rest encryption. We will deep dive into most of these features separately. In this demo, we would use RDS to create a MySQL database instance within free tier with MicroDB instance class, 20 GB of storage, and automated backups enabled with a retention period of a day. We'll deep dive into most of the advanced features in separate upcoming demos. Let's navigate to the RDS console. Amazon Relational Database Service is a managed service that makes it easy to set up, operate, and scale a relational database in the cloud. Before we start creating the RDS instance, we would need to create a subnet group. A subnet group is basically a collection of subnets, typically private, that you can designate for your RDS clusters running in an VPC environment. For RDS nav, you must use a subnet group even if creating single DB clusters. Multi-AZ DB instance requires you to configure VPC subnets in at least 2 AZs. And multi-AZ DB cluster requires you to configure VPC subnets in at least 3 availability zones. Let's select RDS subnet groups. Create a DB subnet group and name it RDS Demo subnet group. Let's copy the same for the description. Choose VPC A. And we will use subnets in US East 1A and 1B. Let's select the public subnets for this demo. Ideally, you would be selecting private subnets, as all storage resources should be privately configured. The configuration seems fine. Let's go ahead and create the RDS subnet group. And the subnet group has been successfully created. Let's navigate back to the dashboard. Use the Create Database section, and you will be provided with the option to select your engine. We'll leave the default to standard create so we can explore the options in detail. RDS currently supports PostgreSQL, MySQL, MariaDB, Microsoft SQL Server, Oracle and DB2. It also supports MySQL and PostgreSQL compatible Aurora DB engine, which we will explore later. For this demo, we will select MySQL DB, which is one of the most popular open source database. Leave the default value for edition and engine version. RDS provides pre-configured templates that provides various options covering high availability and durability to the database. Production template provides high availability and fast, consistent performance. Multi-AZ cluster creates a DB cluster with a primary DB instance and two readable standby DB instances, with each DB instance in a different availability zone. This helps provide high availability, data redundancy, and also increases capacity to serve read workloads. Multi-AZ deployment will automatically provision and maintain a synchronous standby replica in a different availability zone. Single DB instance creates a DB instance without high availability, and it is usually good only for dev and testing environments. The dev test template defaults to a single DB instance. For this demo, we will select the free tier template. Once you select the free tier, the multi-AZ options are not available and a single DB instance would be created with the instance class and storage within the free tier. We'll now configure the DB instance through settings. DB instance identifier provides a name for the DB instance that is unique for your account in the region you selected. For this demo, we will keep the default database 1. Master username can be used to log in to your DB instance. Let's leave the default admin for now. Optionally, you can store the database credentials in AWS Secrets Manager as well. Now, AWS Secrets Manager helps you manage, retrieve, and rotate database credentials, maybe API keys, and other secrets throughout their life cycles. With AWS Secrets Manager, you can actually replace hard-coded credentials in your code, including database passwords, with an API call to Secrets Manager to retrieve the secret programmatically. RDS integrates with Secrets Manager to manage master user passwords for your DB instances and multi-AZ DB clusters. We'll deep dive this in a separate demo. For now, we will enter the master password for the master username. You can optionally choose to auto-generate it as well. Confirm the password by retyping it. Let's configure the instance configuration and storage. DB instance class is pre-selected with T3 Micro, which has 2 virtual CPUs and 1 GB of RAM. Storage type is general purpose SSD, and allocated storage of 20 GB is good for the demo. You can scale up to a maximum of 64 TB with Amazon RDS for MySQL. Optionally, you can enable storage auto scaling to enable RDS to automatically scale up the storage based on the demand. We will disable it for now. In the connectivity section, we can provide information that RDS needs to launch the MySQL DB instance. For compute resource, choose Don't Connect to an EC2 compute resource. We can actually manually set up a connection to a compute resource later if required. We will select the custom VPC A. We need to provide a subnet group for RDS even for a single DB instance deployment now. For multi-AZ deployments, you need to provide a subnet group with subnets in 2 different availability zones. Let's select the newly created RDS Demo subnet group. Choose Yes for public accessibility. This will allocate an IP address for the database instance so that we can directly connect to the database from our own device. However, note, it is recommended to host your database in private subnets with public accessibility disabled. For VPC security groups, we will leave it to default VPC security group, which allows all inbound and outbound traffic. This is not recommended for production setup though. We do not have any preference for availability zones for this demo. AWS would place it within the best available availability zone. If required, you can always place it within any of the AZs that you defined in the DB subnet group. Leave the RDS proxy in the unchecked state. By using RDS proxy, you can allow your applications to pool and share database connections to improve their ability to scale. Certificate authority helps use SSL or TLS for your applications to encrypt a connection to the DB instance. We will leave it to the default certificate. Additional configuration has the port. Let's leave it to the default value of 3306. In terms of database authentication, RDS supports several ways to authenticate database users. Password, Kerberos, and IAM database authentication use different methods of authenticating to the database. IAM database authentication helps authenticate to your DB instance using IAM database authentication. IAM database authentication works only with MySQL and PostgreSQL. With IAM authentication method, you don't actually need to use password when you connect to a DB instance. You use an authentication token instead. Let's choose password authentication from the list of the options. In terms of monitoring, let's leave Enable Enhanced Monitoring unchecked to stay within the free tier. Enabling Enhanced Monitoring will give you metrics in real time for the operating system that your DB instance runs on. Let's explore the additional configurations. Database options cover database name that helps specify an initial database name. If you do not provide a name, RDS will not automatically create a database on the DB instance that you are creating. DB parameter group helps specify engine configuration values, which can be reused for multiple DB instances. Parameters can actually be static and dynamic. While changing static parameters requires a reboot for the DB instance to take effect, dynamic parameters can be changed and they take effect immediately. We will leave it to the default parameter group. With option groups, you can enable and configure additional features which are specific to the DB engines. Leave it to the default value as well. You can enable automatic backups for your database. The backup retention period can be configured for the number of days you want to retain the backup. It can be configured as 0, where backups would be disabled, and up to 35 days. We will set it to 1 day for now. The backup window helps specify the daily time range during which RDS takes automated backups. You can choose a window or use the default of no preference. Let's keep the default. Leave the copy tags to snapshots checked and backup replication to other region unchecked. Encryption provides data at rest encryption for the RDS instance. Let's keep it checked with the default RDS KMS key. Log exports unchecked. Auto miner version upgrade checked will automatically upgrade to new miner versions as they are released. The automatic upgrades occur during the maintenance window for the database. We do not have any preference for the maintenance window. Deletion protection helps protect the database from being deleted accidentally. While this option is enabled, you can't delete the database. Let's leave it unchecked for the demo. You can review your monthly cost, but if you are in a free tier, there will be no charges. The configurations look fine, so let's go ahead and click Create. DB instance is now being created. Depending upon the DB instance class and storage allocated, it could take several minutes for the new DB instance to become available. We'll wait for the DB instance to be available. The DB instance will have a status of creating until the DB instance is created and ready for use. You can connect to the database when the state changes to available. The DB instance is in the available state now. Let's click the Database 1 instance to check on the configuration. On the connectivity and security, you can see the endpoint and the port. The endpoint is the one that we would use to connect to the DB instance. Networking covers the VPC, AZ, subnet and the subnet groups. Security has the default security group, public accessibility enabled, and the SSL certs. No connected compute resources or proxies configured for this instance. Security group rules have all inbound and outbound allowed. Monitoring covers the matrix. It is basic monitoring matrix, and as we have not enabled enhanced monitoring. Logs and events show the alarms and the events. You can see the events for DB creation, upgrades and restarts. Configuration covers the instance ID, engine, option and parameter groups, and the deletion protection flag. Instance class with the resources. IAM, DB authentication and multi-AZ is disabled for the database. Storage encryption is enabled with the default KMS key. Performance insights has been disabled as well. There are no zero ETL integrations. For maintenance and upgrades, we have automatic miner version upgrade enabled and backups enabled for a day. There are no explicit tags created, and the recommendations are empty for now. Let's go ahead and connect to the DB instance now. We'll copy the DB instance endpoint, and let's open a terminal. We already have a MySQL client installed. Use the MySQL command line with the -h for host, -u for the user, and -p for the password to connect to the DB. We'll input the password and we are connected to the MySQL DB instance. We can explore the DB instance further. Let's list down the available databases, and it works. Let's use the MySQL database. Let's show the tables within the MySQL database, and it works. So that's it for the RDS Introduction demo, where we created a DB instance and successfully connected to it. I hope you liked it. Thank you all.
Alright, that was it. Thank you for watching. You can check out my website and connect me on LinkedIn and Twitter. If you enjoyed this video, please give it a thumbs up. For any feedback, please leave a comment down below. To see more videos like this in the future, hit the subscribe button. Thank you.